This is the second part of the circulatory system. We're going to start off with a cardiac tamponade. This is a compression of the heart by an accumulation of fluid in the pericardial sac. It puts pressure on the heart, which may prevent it from pumping effectively. An emboli, this is a clot or other plug carried in the circulation, can be forced into smaller vessels and obstructs the circulation. Arteriosclerosis, so it's broken down into arteriosclerosis, which is hardening of the arteries. Healthy arteries are flexible and elastic, but over time the arterial walls can harden, can restrict blood flow to organs and tissues. And the other type is atherosclerosis, and this is a specific type of arteriosclerosis. You have narrowing of the arteries due to a buildup of plaque, and plaque contains fats, cholesterol, and other substances which can restrict blood flow. These plaques can burst, triggering a blood clot in any artery of the body. An aneurysm. This is a weakening and resulting local dilation of an arterial wall. So this first one, this saccular, is also known as a berry aneurysm, and these are 90% of cerebral aneurysms. The fusiform right here, this bulges out on all sides, and a dissecting aneurysm results from a tear along the length of the artery in the inner layer of the arterial wall, causing blood to leak in between the layers of the wall. John Ritter, I don't know if you know the comedian, but that's what he died of. And actually that's what my mom died of, a dissecting aneurysm. She had it in her aorta. Thrombohlebitis, this is an inflammation of a vein with the formation of a thrombus on the vessel wall. This is an abnormal mass of platelets is formed, then the mass deposits on the vascular surface. Affected vein may be partially or completely obstructed. It usually occurs in the extremities, usually the legs, the superficial veins, and the deep veins. Varicose veins are swollen, tortuous, knotted veins, usually occur in the lower leg, caused by damaged valves that fail to prevent the backflow of blood. So you have decreased blood flow, results in increased risk of thrombosis. Thromboangiitis obliterans. This is also known as Buerger's disease. This is an inflammation of the peripheral arteries and veins of the extremities with clot formation. Raynaud's disease. This is a vasospastic condition of the fingers, hands, or feet. And you notice how their fingers are different colors. Sometimes they can be redder, blue, white. So, it's a reaction to the cold. Okay, so let's talk about the anemias. First one is the iron deficiency anemia is due to an insufficient iron. The body can't produce enough hemoglobin. This causes what they call a microcytic anemia, or the red cells are very small. And you can tell because this is a normal lymphocyte right here, and the red blood cells are smaller than that, so they're microcytic. Folic acid deficiency. This is deficiency of folic acid, which is vitamin B9, and folic acid is necessary to make red blood cells. Now, B12 and folate deficiencies cause macrocytic red cells. Pernicious anemia. This is a deficiency of vitamin B12. The absence of intrinsic factors secondary to gastric atrophy. Okay, the parietal cells of the stomach secrete hydrochloric acid and intrinsic factor. Causes of this: a diet lacking in vitamin B12, you're missing meat, eggs, and milk, or the small intestine can't absorb vitamin B12 because of lack of intrinsic factor. Aplastic anemia, the bone marrow and stem cells are damaged. Stem cells cannot generate mature blood cells, so you have a pancytopenia, which means the platelets, red cells, and white cells are all affected. Sickle cell anemia causes red cells to form a sickle shape, can clump together and block blood vessels, and this is what's bad, okay, because then the blood can't get through. You have ischemia, you could have tissue death. There's a defect in the beta globin gene. The valine is substituted for glutamic acid in the 6th position. That's it. That's the only difference between normal hemoglobin and sickle hemoglobin. A normal red cell lives 90 to 120 days. The sickle cell lives approximately 20 days. In sickle cell disease or sickle cell anemia, the supply can't keep up with the demand. Now, we're going to just go over leukemias real quick. So let's talk about cell development. Leukemias are malignant neoplasms of the blood-forming organs that produce an abnormal, uncontrolled clonal proliferation of one specific type of white cell in the lymphoid or myeloid lines. And it's caused by damage to DNA of the developing cells in the bone marrow. So we have this, what they call a pluripotent blood stem cell. Okay, this is the mother cell, and that breaks off into the myeloid stem cell and the lymphoid stem cell, and they go on to produce the different blood components. Now, the leukemias are classified by 2 ways. They're cell type, and they can be myeloid, which is the granulocytes, the monocytes, and the megakaryocytes, or lymphoid, that's where you find your T and B cells. Or cell maturity, you can be acute, and those are immature cells, sudden onset, many peripheral cell blasts, peripheral blood blasts. And chronic, you have mature cells, slow, insidious onset, few peripheral blood blasts. So the 4 major types are acute lymphocytic leukemia, acute myelogenous leukemia, chronic lymphocytic leukemia, and chronic myelogenous leukemia. Lymphedema. This is an abnormal collection of lymph, usually in the extremities, and it results from a blockage in the lymphatic system. Hodgkin's disease. This is a lymphoma, and the characteristic finding is the Reed-Sternberg cell, and that's what this little guy is. To me, he looks like a little owl with 2 eyes. Non-Hodgkin's lymphoma. This is a cancer that originates in the lymphatic system. There are several subtypes. The 2 major subtypes are the B cell and the T cell and natural killer cells. Okay, the B lymphocyte, which is the most common, this is 30% of the non-Hodgkin's lymphoma is diffuse B cell lymphoma. Now, the natural killer cell type lymphoma, and then the peripheral T cell lymphoma. Those are the types. Transfusion incompatibility reaction. The blood product transfused has antibodies to the recipient's red cells, or the recipient has antibodies to the donor red cells. And this is the coagulation cascade. All it does is showing you that it starts here. This is the intrinsic. The intrinsic means you have everything you need inside the body, and this extrinsic, my God, I can't talk, has to do with, okay, so you have a cut, and what that does is you are messing with the endothelial lining of the vessel, okay, and it causes it to change shape, there's a lot of changes going on, and then that activates this extrinsic pathway. But ultimately, both these pathways lead to a common pathway, and that makes thrombin, and that converts fibrinogen to fibrin, and then this forms a stable fibrin clot. Okay. So the test, the PTT, or the partial thromboplastin time, measures the intrinsic system, and the PT, which is the pro time, measures the extrinsic system. Okay. Now, plasminogen is converted to plasmin through TPA, which is tissue plasminogen activator, and that digests the fibrinogen and fibrin. The classic hemophilia is hemophilia A. It's X-linked recessive, and it's a deficiency in factor VIII. This is a hereditary bleeding disorder. Okay. So you'll have decreased factor VIII activity, you'll have a normal PT, a normal bleeding time, normal fibrinogen level, and an increased PTT. Remember that PTT was for the intrinsic system. And the last one is disseminated intravascular coagulation, or DIC. This is a microangiopathy. There's a disruption in the body's clotting mechanism. The body overproduces many small clots throughout the body, depleting the body of clotting factors and platelets. These small clots are dangerous and can interfere with blood supply to organs, causing dysfunction and failure. Massive bleeding can occur due to the body's lack of clotting factors and platelets. DIC is life-threatening and needs to be treated promptly. So because all these factors are being used up, you have an increased PT, increased PTT, a decreased platelet count, a decreased fibrinogen, increased thrombin time, and an increased D-dimer. And that is it.